Good afternoon, good afternoon, good afternoon. My name is Dr. Calvin Mackey, coming to you from STEM Nola, and I'm always humbled by the fact that people have signed on and tuned in for one of our at-home lessons. Thank you all for doing this. In 2020, post-COVID, we pivoted to virtual, and we engaged over 16,000 scholars from 47 states and 5 countries, and it's still going. And guess what? We have no desire and there's no possibility that we're going to stop. As long as you all keep tuning in, as long as you keep telling your friends, telling your schools, and more people keep signing on, we're going to keep delivering great content for you. Again, thank you. This is a great day. The lesson today is chemistry. You're going to be doing some great things. What they doing? They say witches brew and PlayDoh. Yeah, PlayDoh. Wow, that's good. We're going to be making witches brew and PlayDoh. So we believe that when your hands are on, your minds are on. At STEM NOLA, we believe STEM should be culturally and environmentally relevant, meaning that you should be able to walk out of your house or walk into your kitchen or just go outside and see STEM all around you. It's not so much about the equations. For us, it's about learning the theory so that when you learn the theory, when they do put the equations in front of you, when they do put all of this complicated stuff in front of you, it makes real sense. STEM NOLA was started in 2013. I have 2 young sons. Well, they are now 16 and 17. One is about to go away to college. But when he was in the 3rd grade, he asked me a question. We started having these discussions. We started going in the garage doing these experiments. Before you know, we had 20 kids in the garage doing these STEM builds and experiments. The kids was learning. My wife and I felt that we was giving our 2 sons something that the community should have. So since 2013, we've engaged over 60,000 young people, over 16,000 families, and over 1,500 college students and STEM professionals. At STEM NOLA, we believe a high-functioning STEM community is child-centered, adult-governed, elder-ruled. So whenever we present, we have content and delivery for our K-12 scholars. Then we have our college students and interns chime in. Today, we have a college student named Lionel Johnson, a junior at Morehouse College, where I went. That's where I'm wearing the maroon and white because of Morehouse. And then we have our professional volunteer to chime in and let you know that this is real. And today we have an amazing volunteer, a manufacturing engineer from BOEING, and she will be speaking to you soon. As a matter of fact, this is Women's History Month, and we want to say congratulations to all the women that's getting up every day and doing the things necessary to create their place in the world. I've always told my sisters and I always told my wife, a woman's place is in the house or the Senate or anywhere other place she wanted to be. You see, y'all was about to get me. My wife is a pharmacist and she's STEM also. And I love to see people, regardless of their gender, regardless of their race, pursuing their dream. I still believe we live in the greatest country in the world. This is the only country in the world where you can get up every day and create a better tomorrow for yourself. We have to just make sure that that's possible for everybody. And this month we celebrate women because if you look at the history of this country, there were times when women did not have equal access to all of the things that men still have access to. So those are the things that we fight for on a daily basis. As a matter of fact, at STEM NOLA, the majority of our employees are women. They tell me what to do. They tell me where to go. And all my life, my PhD advisor, Dr. Carolyn Myers, who was just former president at Jackson State University, told me, you're going to be a doctor. I listened to her, and today, 25 years later, I'm still Dr. Mackey. Listen to the women in your life, all right? So, parents, in the 21st century, our children are going to have only 3 options. Either they're going to take something, make something, and or break something. If we don't give them the skills and education to make something, like make a living, make a difference, make a life, that only leave them with the 2 options that you see on TV every night, and that's to take and a break. And we don't want that for any of our kids. Right now, the country, the world is going through a traumatic transformation called automation. Companies are rushing, especially with COVID, to automate their processes, meaning that now they have machines doing the work that people used to do. And my dad used to always have a saying. He said, son, I hate to be the last man selling saddles when Henry Ford has created the Model T. And you know, the Model T is going down the street. The Model T is 5G. It's machine language. It's, it's data science, all this new technology that's being applied, and we don't want our children standing on side the street with a horse saddle of skills of the 20th century and not skills of the 21st century. We're either gonna train our children from the neck up, or we're gonna train our children from the neck down. And if you're training your child from the neck down, if the schools are training our children from the neck down to do physical work in the 21st century, their competition will be the automatic machine. And this is Alpha. Alpha is a humanoid. A humanoid is a robot that attempts to behave like a human. Alpha can do many of the things physically that we can do. Alpha can do push-ups. Alpha can show off. Get it, Alpha? Alpha takes a long time getting up, just like me. And for all of you all out there who want to go into the dance business, Alpha can dance. Come on, Alpha. There you go. And just like Beyonce, Alpha comes with her own music. This is a humanoid built by a company called UB Tech Robotics, the largest commercial robotic builder in America. And guess what? UB Tech is making life-size robots right now. But then they say within 10 years, all of us can have our own personal assistant that follow us around and do tasks for us. But guess what? They're also building robots to do manual labor in warehouses and healthcare and things like that. This is the competition. Either in the 21st century, either we're gonna control the robots or the robots are gonna control us. We want you to train your heart and your head so that you can control a robot and the machines do not control you. So we got it, good. That's why we're here. That's why we do what we do. And today we're doing chemistry, and as you can see, you can build all the machines you want, but you can't build them without chemicals, without circuits, and all the different things, even biology, the things that we go into. Now, we want you all to send pictures. When you do something, send us pictures so we can share with our sponsors. And my good friend, Kayla Gilbo from Abeka Academy in Lafayette, thank you for sending in a picture. Shayla Washington and Lacey Jasmine in Shreveport, thank you all for sending in a picture. I hope you all participated in STEM Grambling and STEM Shreveport. We have an event coming up, and we need you all to register. And my buddy Javen Moore in Kernersville, North Carolina, keep putting it down, Javen. We're proud of you. That's a great picture. Send your picture to webinar@stemnola.com. Now, I will introduce to you, BOEING is one of our major sponsors, our major partners, and we're always happy to have BOEING engineers and BOEING workers to come and share with you. Today we have Abisoye Adujumo from BOEING. She's a manufacturing engineer and attended Texas A&M. Abisoye, thank you for joining us today.
Okay. Yes. Okay. So, like the doctor said, the topic today is chemistry, but my name is Abisoye, and I am a BOEING engineer, manufacturing engineer. I have a master's in chemical engineering. I also have a bachelor's in chemistry and chemical engineering. And I went to Texas A&M, and currently I work with TPS, is just a thermal protection system on the space rocket. And so I'm going to talk about TPS, thermal protection system. But before I talk about that, I just want to give you something so you can always relate it to it. So for chemistry, before you get to, I'm going to talk about a material, which is the TPS, but chemistry is mainly studying everything at a small micro level. That way it's like a puzzle. You're trying to understand each part of that puzzle so you can be able to fit it in the right position very well. So in the case of TPS is just a combination of several atoms and molecules that came together in an effective way to become something brand new, which is a material called TPS. And TPS is mainly for SLS, which is um, here in New Orleans. We mainly work with the foam, the caulk, and the Ipolon. Ipolon is just the paint, is the chlorosulfonated paint. And so what is TPS? TPS is an insulator. It is a required, when you look at the picture on the right side, I intentionally had it that so you can see the whole external surface is all TPS, and TPS covers almost all the whole body of the rocket. So the reason why TPS is required is because of the property it has. It's very good insulator. Like when you're a scientist or engineer and you want to create something, you have to think about what you want that thing to do. Do you want it to do this and that? In this case, we want it to be a very good insulator. So it keeps the environment inside the rocket constant, and it also keeps the environment outside and the surrounding from entering into the system. So that is why we like we use a TPS. So like for the rocket, for instance, during the time it's going to the space and it's coming back, it goes through temperature as much as 3,000 degrees Fahrenheit. And so that is very, very hot. And that would normally interfere and go into the system normally, but because of the property of the material TPS, specifically the foam and the caulk, it prevents um, heat of that nature. So can we? So this is just, I added a picture so you can see how TPS looks when it's on the surface of the rocket. And the second picture on the right is just so you can see one of the application while they're applying it on the surface as well. So like I said, one of the property of TPS is the caulk and the foam is to be a good insulator. It also must be able to prevent all this phenomena from occurring, like for instance, the conduction, the convection, and the radiation, and also the thermal conductivity. It must block it all to almost zero. We know in real life, there's nothing that is almost zero, that is zero, but so it's almost zero. So it does block conduction and convection radiation. What is conduction is just when the heat on one body transfers the heat to the other body. And in the atmosphere, that is constantly occurring. And also the convection is just the heat from another source that is being carried to another source, in this case, to the rocket. So by air or fluid. So like for instance, I'm gonna give you an example that you might be able to relate with, like your oven at home. Sometimes, not all of it, sometimes some of it goes through convection heating. That means something else is hitting it, then the fan is carrying the heat to the food. So that is one of the ways that the heat in the atmosphere can get to the rocket. And the third one is radiation. You know, radiation when you're outside in the sun and all of that. So in the atmosphere, it's also occurring radiation. Heat is being passed via radiation. That means heat is going via waves or rays to another body, and this is to the rocket. So the thermal conductivity is just the ability of a material to resist heat, and the TPS is able to resist heat enough that it can protect the core of the rocket. Next one. Okay, so So we've talked about the cork and the foam. The third element of the TPS is the Ipolon paint. The cork and the foam protect the rocket, but what protects the cork and the foam? It is the Ipolon paint. So what that does is that it protects it from moisture, either in the air or even when you're about to to ignite the rocket. For instance, you might wonder, how does, besides the rain and the condensation and all of that, how does moisture get to the cork? When the rocket is about to be ignited, that's when it's about to shoot up. it it uses hydrogen and oxygen as its fuel, and hydrogen and oxygen is very good fuel. It's not like crude oil that the cars use now or have been using for years. So hydrogen and oxygen is very good fuel system. So what happens is that hydrogen is on the periodic table. Hydrogen is on the left side, and oxygen is towards the right. So they combine. Before I talk about that, I want to tell hydrogen occurs naturally in a gaseous state. So we have to decrease the temperature and make it very cold, like what we call cryogenic cold, so that it will shift to liquid. When you're in school, in college, you're going to study something called phase diagram or thermodynamics, and you understand better. So it gets to be liquid. That way we can put it in the tank. So when they're in the tank and there's time, we usually fill it in the tank when it's about to leave. So we'll fill the tank and then we ignite, and the oxygen and the hydrogen find its way to the rocket chamber, and that's where combustion takes place. Combustion is just when substances are burning, so they combust and combine together, and when they combine together, energy, massive energy, and water in form of superheated steam is released. And when it is released, it powers, it gives the rocket its ability, just like, I think it's the third law of Newton's third law or something, that opposite reaction. So it goes to the opposite side and the rocket flies to the other side of it. So, but the steam can settle on the surface of the rocket, but the Ipolon protects the moisture from penetrating into the material and all of that. So that is what TPS does, and the Ipolon and the cork. And so there's something I forgot to mention. I want to just quickly mention, it's very important. When the rocket is returning from space to the Earth, remember when you're trying to fly from the staircase downward, it's very easy to come down, but it's not easy to go up. So when it's coming down, it goes through so much intense speed that it creates friction with the surrounding element, like gas, compression, and all of that. And so it generates so much heat that it's like a fireball. If it wasn't for the TPS that doesn't let the rocket absorb all the heat and preserve it, you just see a fireball coming down to the earth. So I just want to mention that that's one of the function of it. So this last slide, I was just sharing when I was in school. In my school, they never give us periodic table sheet. We have to know it here. So I had this mnemonics. It's not on Google. You're not going to find it on Google. So it's original. So it's just to help you remember each element from the first letter to the element, and also by counting your fingers, you can know the atomic number and atomic weight. The atomic weight is just you double the atomic number and it becomes the atomic weight. In some cases, you will double it and then you add one, but when you start using it, you get used to that. But for you guys, you're probably going to focus only more on the first 20 elements. That's why I added it here. And it's just, it has little brain, but cannot offer full natural science. Many ask students improve science courses as for career. So that's just what it is. So that's just an extra tips for you to get going. And This is just a joke, organic chemistry joke. So thank you.
Thank, am I on? Thank you, Abisoye. Give her a hand. You know, Abisoye, my PhD is in mechanical engineering, but in mechanical engineering, I studied fluid mechanics. Really, I studied thermal science, which was heat transfer, thermodynamics, and fluid mechanics. So what you was talking about make a lot of sense to me. Young people, thermal protection system, like they have to wrap that big tank to get it up into space when it enters re-entry. They have to make sure the heat, it can protect it from the heat. Last week in America, everybody needed a thermal protection system, especially the people in Texas. You understand what I'm saying? Because it was cold. So when you learn chemical engineering per se, and you learn mechanical engineering, there's a bunch of different aspects. I went into mechanical engineering because I thought I wanted to work on engines and cars. I left mechanical engineering as a doctor working on fluid mechanics and study how stuff move, how stuff flow, all that crazy stuff. But let's move on. Thank you, Abisoye. And thank you to the Boeing Corporation for allowing your employees to take time out of their busy schedule to pour into the community. Next up, like I said, our community, we've had professional. You are the K-12 students. And now we're going to bring up one of our college interns, Lionel Johnson, a third-year junior at Morehouse College. His major's in sociology and theater. So just think about that, right? I think he'd be acting around here like he's working. So he's a good actor. But I went to Morehouse College, so I'm always happy when one of my little Morehouse brothers show up and show out. So you better not embarrass me.
Yes, sir. Ready?
Lionel Johnson.
How's everybody doing? I hope we're doing well. Thank you, Dr. Maggie, for that great introduction. As he said before, my name is Lionel Johnson. I'm gonna take my mask off for you guys. As he said before, my name is Lionel Johnson. I go to Morehouse College in Atlanta, Georgia. My major is sociology with a minor in theater. And let's get started today, guys. I'm ready. You guys ready? About to have some fun today. All right. So today we're going to go through a couple things. Let's stay connected, guys. We have some vocabulary terms we're going to go over first. Then we're going to move on to our objectives. Then we got some activity questions. We're going to do some activities like the witch's brew, some Play-Doh. And then when we're finished with that, we're going to have some activity question and answers. So I hope you guys stay tuned in and ready for a ride. Let's go. Okay, let's start with our vocabulary. So first, a chemical reaction. A chemical reaction is a process that leads to the chemical transformation of one set of chemical substances to another. Basically, I have a demonstration for you guys. When you mix like water with an Alka-Seltzer and it fizzes up, that's a chemical reaction. So I'm going to show that to you guys for a second. Okay, I got you. I got you. All right. So I'm gonna break it up a little bit so it's not too bad. When I drop this in here, see how it's fizzing up? Just like that, I'm gonna drop another one. And I'm gonna drop my last one. You see the reaction that the water has when the Alka-Seltzer has been dropped in? That's basically what a chemical reaction is, just to show you guys on an easier level to see without just reading the words. So I'm gonna go bottle this up with it because I'm done with it. I'm just gonna put it to the side, thank you. Next, we have carbon dioxide. Carbon dioxide is a chemical compound that is usually in the form of gas. It is made up of one atom of carbon and two atoms of oxygen. Its chemical formula is CO2. I want you guys to remember every vocabulary that I give you guys. So an example of carbon dioxide would be when we breathe in oxygen, you would think that you release oxygen, but you don't. You release carbon dioxide back into the air, which is not, this might not be a word, but rebreathable. You can't breathe back in carbon dioxide. You have to breathe in oxygen, and what you breathe out is carbon dioxide, guys. Next, we have a molecule. A molecule is a group of atoms bonded together, representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. Now, a solution. A solution is a special type of mixture composed of two or more different substances. So a good demonstration would be mixing Kool-Aid with water. That's a solution. So if you guys ever done that, ever had some good Kool-Aid, that's you're drinking a solution. That's basically what that is. Now, as you can see, there might have some agenda questions that you have. I'm going to read it to you guys. What is the formula for water? I'm going to give you guys a couple seconds to answer that. Okay. So we see we had about 20 of you guys get the right answer. So I'm glad that you all are paying attention and you guys know what the chemical formula for water is. Let's move on to the next question. Oh, that's the end of the questions. So for our objectives, today you will understand the meaning of the terms chemical reaction, carbon dioxide, molecule, and solution, and all apply them all to the project correctly. You will do an experiment making witch's brew and Play-Doh, like I stated earlier. So I hope you guys are ready to have some fun, man. Next question. What are we building today? I'm just kind of curious to see what you guys are thinking. What are we building? Okay, I see. Everybody's answering. Okay, we got some smart people in here today. Shakita, I'm about to tell you the right answer in a couple seconds. Okay, Play-Doh and witch's brew is the correct answer. I see a couple of us got it. One of us are off, but hopefully we can move on and all get the correct answers. Now, for the questions of the day. What gas is formed when you mix baking soda and vinegar together? Don't answer this yet. Just make sure that you can comprehend these questions because I'm going to come back to them and we're going to review them. So what gas is formed when you mix baking soda and vinegar together? Question number 2 is, what is a chemical reaction? Question number 3, what is the chemical formula for carbon dioxide? I want you guys to remember these questions. We're going to come back to all of them. Now for the fun part, ladies and gentlemen. Let's get to our witch's brew. Okay. I need the paper that I was using, the instructions for it.
Where is it?
It should be in the back room by Keith. He's in the other room. Okay, so I'm going to go over the materials for you guys. We're going to need baking soda, vinegar, food coloring, dish soap, plastic cup, and glitter. In a few seconds, I'm going to tell you how much you need and what supplies that you need to really make sure that you have a clean place to work on because it's going to get a little messy, parents. So if you want to have a big open space to do the witch's brew, that would be recommended. So I'm going to give you guys a few moments to go and find these materials around your house if you don't have them in front of you already. So while you guys are doing that, it's in the back room. Yeah, it's sitting by Keith. While you guys are doing that, I'm going to go over the science behind it. Anytime you have a reaction between vinegar and baking soda, you get bubbles. When the two chemicals mix, they release carbon dioxide gas. When you add soap, the carbon dioxide blows air in the soap solution, creating larger bubbles and making a better explosion. So, like I said, I was going to tell you guys how much you needed to for your materials. For your baking soda, you need 2 tablespoons of baking soda. You need a half a cup of vinegar, and a 9-ounce cup is recommended. A 9-ounce cup is recommended, but if you don't have that, just something close to that, parents. Food coloring, dish soap, the 9-ounce plastic cup, and some glitter to make it all glamoury. All right. I'm going to get my materials in front of me, and I'm going to do this with you guys, so stay tuned. I'm just going to get my materials here for a second, guys. Pardon me. Okay. As you guys can see, I've already filled up my cup with vinegar. And I want to get my food coloring that I have here, as you guys can see. I want to get my glitter. I want to get my dish soap. How much vinegar do you have? You need to have half a cup of vinegar. So basically, this is the cup that I'm using, if you guys can see. This is the cup. I filled it up halfway, and this is a 9-ounce cup. So if you guys have this in your home, this would be recommended. But if not, you can have something close to this and just fill it up halfway if it's not too much bigger than this. Okay, so the first instruction is to fill your plastic cup halfway with vinegar. Cool. Next, I want you guys to add the food coloring like this and the glitter to the solution and stir. Just like this, guys. Add you some food coloring. Some food coloring, some glitter. Then we're going to stir it up. If you guys watch any superhero movies like Batman, this kind of is giving the colors of the Joker, you know, the villain that he fights sometimes to save the world. I know you guys know who those two guys are. How much baking soda do you need? You need 2 tablespoons of baking soda. This is my baking soda right here. You need 2 tablespoons. So I'm going to mix this up, guys. Mix it up really good so you can get the best color solution that you want for when you get the big old explosion. Now, after that, I want to get my dish soap, as you guys can see, and I want to put a lot of it in there. Not too much, but enough that, you know, you'll be able to see it a little bit when it's going in. So just like this, I want to pour a lot, just like that. The more you put, the more explosion you'll have. So parents, be aware of that. You don't want too much baking soda, everyone. So just get 2 tablespoons. That's the most you need. All right. So I'm going to recap some of the instructions that I gave you. First, I want you to fill your plastic cup halfway with vinegar. I want you to add food coloring and glitter to the solution. This is what my food coloring looks like. And this is what my glitter looks like. I want you to add that to the vinegar. Then I want you to mix in the dish soap like I did a moment ago. And I'll give you guys a few seconds to do that before I pour my baking soda in for the grand finale. I hope you guys are having fun because I'm having a blast. We'll wait a few more seconds for everyone to get acquainted with their experiment. I hope you guys have your favorite colors out. How much baking soda do you need? You need 2 tablespoons. Oh, you did the Batman, the Brave and the Bolds? That's awesome. That's wicked. I wish I could experience that. I love Batman. Batman's my favorite character, my favorite superhero. You guys go ahead and say who your favorite superhero is in the comment section if you guys are all caught up. All right. Wonder Woman, okay. Wonder Woman's cool. Spider-Man, all right. Those are some cool people. Captain America. Yeah, that's some of the best heroes. Deadpool, that's a new one. Healthcare workers, I love that answer. They are definitely superheroes too. Superheroes without the cape. They deserve one though. Okay, Joker. Yeah, all right. So to move on to the fun part. This is my baking soda. If you want to, you guys can record this part, record your own. But let's get to it. I want you to pour all your baking soda into your vinegar, dish soap, and your glitter. Here we go. Uh-oh. The Joker's about to come alive. Here he comes. Uh-oh. Uh-oh. Wow, look at that. Look at that. Look at that. Oh my gosh, it's overflowing. It is overflowing. Wow. I should have brought a bigger bowl. Man, that is so cool. You guys like that? Make sure you send your pictures at the end. Take a picture of it now so when it's done, it doesn't look the same. Take a picture of it now and get ready to send it to the email that I give you guys at the end. This was a great experiment. I hope you guys had so much fun. And I want to move on to the next one. That was just so much fun, guys. I hope you guys had a blast doing that one. I'm going to do that again when I get home. Okay, I'm just going to move this, guys. Okay, so now I want you guys to really just clean off your area because we're about to get a lot messier. So parents, beware of that if you want to supervise what the youngins are doing. The future of our country and the others. Okay, so now, Play-Doh. One of the best things since sliced bread, everyone. I mean, literally. So, back to materials. We're gonna get 4 cups of flour, and I'm gonna show you guys everything. 4 cups of flour. This is what it should look like. 2 tablespoons of vegetable oil. Some measuring cups. 4 sandwich Ziploc bags. A clean countertop, so somewhere that's really clean and you just have space to work, okay? 1.5 cups of salt. Your favorite's Batman, mine too, man. We're twins. You want 1 cup of water, warm. Make sure it's warm. That's when you get the best solution of Play-Doh. You want 1 spoon. Oh, where did my spoon go? And 4 small bowls with 1 large bowl and some more food coloring. Food coloring, that's for what you want your Play-Doh to look like, what color that you want it to look like. So, oh, Kyler, your favorite's Batman also? We got 3 twins. We're triplets. That's awesome. Okay, while you guys go and get all of these ingredients for the materials that you need, I really just want you guys to know the science behind all of this and what we're about to do. So, when dry salt and flour combine together, produces a mixture in which the salt forms a matrix around the flour particles. I'm going to describe everything to you guys, so if you guys are confused, don't worry about it. When you add the water, it becomes a solution. Once the flour absorbs the water and the solution has... No, Shakia, please don't eat this. Please, I beg of you. If your parents are around, please do not eat it. But once the flour has been kneaded... Oh, Kennedy? Okay, cool. Once the flour absorbed, the water and the solution has been kneaded, it leaves the salt behind, which cements all the flour particles together, making Play-Doh. All right. I'll give you guys a few more seconds. So what? What's up, Javen? What's up, man? I'll give you guys a few more seconds to really just get all your materials together while I get all mine together too. Okay. Okay. In the large bowl of my flour, I want to mix together 4 cups of flour and 1.5 cups of salt. So basically, guys, you want to take all your flour, you want to take all your salt, and you want to pour it in the bowl, just like so. Make sure you get it all equally around. Just like this. Make sure you show love to all parts of the bowl, man. Equality is the best thing. That's what we all fight for. And now I'm just gonna mix it up, guys. Now I'm mixing all of this just to show it to you guys, but I'm only gonna do 2 balls of Play-Doh. You guys are gonna do 4. So if you wanna give it to your friends, you wanna give one to your mom or your dad or your cousin, auntie, uncle, anyone, you can do that. I'm just gonna do 2 with you guys to show you how to do it. Is that cool, everyone? Y'all fine with that? Okay. Now, I want to pour warm water into 4 small bowls. You want to pour 1/4 of a cup into each bowl, but I'm just going to pour half into each of my bowls. I'm going to use these 2. Okay, warm water. Let me get it. Pour some warm water up in here, guys. Cool, I'm gonna pour a little bit more. Perfect. Okay, now you want to add a 1/2 tablespoon of oil to each. So basically, I want to do this. Just like this, just a little bit, guys. I'm gonna pour a little bit more than you guys because I'm only doing 2, but with the 2 tablespoons you have, you want to distribute it equally amongst 4 bowls, okay? Perfect. Now, I want to add 1 cup of flour salt mixture from step 1 to each of the 4 small bowls and mix together until it is smooth. Okay, guys, the way I'm gonna do this. Okay, you guys, I'm gonna repeat that step again. Add 1 cup of the flour salt mixture from step 1 to each of the 4 small bowls and mix together until it is smooth. So while I do that, I'm gonna get my stuff ready to do that in my 2 bowls. I just wanna mix it up a little more just to make sure that the salt and the flour have mixed together perfectly. Just like this, guys. So I want to take this. You see how it says 1 cup on it? 1 cup. I want to take it. I want to take my mixer out. Do just like this. And make sure it's 1 full cup. Shake it off the excess. And just put it in there like that. Woo. I might need to add a little more, but we're just gonna see what that does so far. Okay. Now, step number 6. Spread a little flour all over a cutting board or clean countertop so that your Play-Doh will not stick. Okay, so guys, I'm not gonna do that part, but basically, if you have a clean countertop that you can get dirty, basically I just want you to just scoop some of the flour out and spread it across the table so that it doesn't stick to the table. Wait, how much Play-Doh? Do you mean flour right now, Giovanna? If you mean flour, then you want to do 1 cup of flour into your bowls with the warm water. Yeah, 1 cup. Okay. gonna mix it together just to get it a little more thick. And if you need to add a little more flour or a little more water to get it either thick or a little looser, then you can. But I want you to just stir it up first just to see. Oh, yeah. Oh, yeah. Okay. So, I'm sorry, guys. I missed a step. You want to add your food coloring in before you stir. It's not the end of the world if you didn't, but if you haven't stirred yet, you want to just add a couple drops of food coloring. So I'm going to do green in this one, and I'm going to do red in the other one. You can add how much you want depending on the color. I'm going to add a lot because my favorite color is red. Let me hear what you guys' favorite color is. I'm deeply interested. Mix it together. Oh, wow, that looks amazing. Wow. I'm going to add a little bit more flour, guys, just to harden it up. I hope you guys are loving this as much as I am, because I am having a blast. Okay. That should do it. You see how it's changing colors, guys? Just like that. You want to make sure it's really tough before you start to mix it with your hands. And I recommend gloves so it doesn't get all over your fingers, but if you want to just go crazy, you don't have to use them. But I would recommend gloves. So as right now, I'm going to put my gloves on because I'm starting to get the texture that I want out of my Play-Doh. This is the fun part, guys. This is where we feel like we're back in the classroom with all our friends playing with the Play-Doh, building stuff, breaking stuff down. Yeah, there we go. Now it's looking real good, guys. Perfect. I'm going to test mine out after I add just a hint of more flour, not too much, just to make sure I'm able to play with it as freely as I want to. Because I'm finally starting to get the texture that I want to make the Play-Doh. Sometimes it takes a little more than 1 cup, depending on how much water you have. Sometimes it can take a little less. It all depends on your measurements. And with the measurements that I gave you guys should be A-okay. Now I'm going to start mixing it with my hands, everyone. Oh, it makes me feel like I'm Chef Boyardee making a nice pizza on a Friday night, you know? You know, you're at home making pizza with your family. Do you guys like pizza? Let me know if you guys like pizza in the comments. I love pizza. What kind of pizza do you guys like? You like pizza? I love pizza. All right, now I want to start making my ball. You love it, Greg? Spinach Alfredo. I've never had that before. You see, I might need to add a little more flour, but it's finally starting to take the Play-Doh shape. And I can pull it apart. But I'm going to add just a hint of flour. And then I'm going to show you guys how to make a ball. There we go. Now it's looking like Play-Doh that comes in the pack. You can make this stuff at home. There we go. And for the grand finale, pepperoni pizza for you. That's my favorite, pepperoni pizza. If If you got pepperoni, you can never go wrong. You see it, guys? If I want to make a nice sphere, you want to roll a little bit harder, or I can make a small one, take it off, make a small sphere. Perfect. Now I'm going to do my next one for you guys, and then we'll be finished with our experiments, the best part. And with all your excess Play-Doh, like I said, you can give it to someone, you can make them things, however you want to do it. But I'm going to go to my next one. I'm going to put a lot of more flour, guys, just to make sure that I like my texture. I'm going to add a little more. Or a lot of more. I'm just going to go dump it. Blah. Perfect. Red, guys. My red is my favorite color. What's you guys' favorite color? Oh, yeah, this is going to be a tough one. I got all this flour, but we're going to make it work. I'm going to add just a hint of water, not too much, just to loosen it up a tad. There we go. Now I want to just really mix it in there. Make sure it's good. Make sure it's looking real good. You see, guys, it's looking amazing. It looks pink. I know, right? It's because all the flour made it a little lighter. But, you know, pink's a nice color, too. You see? Just like that. Almost looks like a heart, you know? Now, let's make a ball. Some off. Oh, look at that, guys. Look at that. That looks amazing. A brain color, right? Green turned to lime and red turned to a... Look at that. Oh, wow. Y'all want to see a magic trick? I'm just going to take it in my hands, take it in my hands, take it in my hands. And now it's all gone. You see? Now it's all gone. But if I just, you know, say a prayer over it, please work, please work, please work, please work, please work. Boom. And there it is again. Abracadabra. You know, I have a lot of excess clay, excess Play-Doh, but I mean, that was amazing, man. I had a great time doing that with you guys. You guys let me know, 1 through 10, how did you enjoy that? 10 being the best, 1 being the worst. Did you guys enjoy that? Was that fun? 10? I like that, Layla. I like your confidence. I like your positivity. 10, everybody 10. I love it. I love it. I love it. 9, oh, why we're not a 10? Why we can't be a 10? Okay, guys, let's move on to the questions. I'm gonna take my gloves off, guys, if that's cool with you guys. What gas is formed when you mix baking soda and vinegar together? That's a hard one. Because you didn't have red? Oh, that's okay. That is all right. It's okay. Okay. Come on, guys. What gas? I'll give you a hint. It definitely starts with a D. Carbon dioxide. There we go. I just wanted to see if you guys were really paying attention. Okay. Okay. All right. See, I even threw you a curveball. You still got it right. I love it. Next, what is a chemical reaction? I have no idea. Can you guys help me with that? I have no idea. What is a chemical reaction? I wish I could give you a hint, but I have no idea what this is. Man. Come on, guys, help me out a little bit, please. I'm struggling. What is a chemical reaction? Okay. There we go. I'm loving it. I'm loving it. Let's move on to the next question, guys. Last question I got for you guys. I'm not going to give you guys a big test. I'm not one of those guys. What is the chemical formula for carbon dioxide? Oh, wow. People have answered it before I even finished. That's the leaders of the next generation. That right there. You know the answer before I give you the question. Maybe you have superpowers. Maybe you can time travel. Maybe. I don't know. I don't know. Oh, wow. 100%. I love it. CO2. I love it. I wish I could time travel too. I love it. Man, this was amazing. I had such a great time, everyone. I mean, from the beginning of Dr. Mackey's speech to our presenter to doing these great experiments. I mean, this might be the best day of my life. Definitely. Nah, this is the best day of my life. So, I remember I told you guys to take pictures. I'm definitely going to take some pictures, you know, of my awesome clay, Play-Doh. We got it all. Take some pictures of that with your beautiful smiles. Send them to webinar@stemnola.com. And look, it was a blast being with you guys.
Take a
Oh, God. Mask up, everyone.
Take a picture. Take a picture. I want a picture. I had my shot, bro. I'm good.
Yeah.
Give it up. Give it up, Lionel. Was this your first one?
Yep.
Oh, give it up for Lionel. Give it up for Lionel. Told you he was a thespian, an actor, up here acting with all those theatrics. No, you did a great job. You did a great job, Lionel. You did a great job. That's what we expect of you scholars. We bring college students in to do this because you know what? One day we know you will be doing it. That is our motto, right? Vertical mentoring. We have the scholars looking up to college students, looking up to professionals. Today we had Abisoye Adejumo from BOEING, a manufacturing engineer at a BS and a MS in chemical engineering. College student working on his undergraduate degree. We're celebrating women. We're studying STEM. I don't know if it can get any better than that. I'm like Lionel. This might be one of the best days of my life. It's one of the best days of my life because you know what? We're getting to serve you. And just a little note, STEM Nola is really celebrating because the cat is out of the bag. We recently won a $1.25 million grant from the Kellogg Foundation. And yeah, that's real good. Anytime they say $1 million, that's real good. And that 1.25 million is to seed, is the initial seed funding on a new 42,000 square foot STEM innovation hub that we will be transforming here in the eastern area of New Orleans. The building was donated to STEM Nola by Oxygen Health System, the largest health system in the state of Louisiana. And we got a lot of work ahead of us, but when we get it finished, we're going to invite all of you all to make a journey, a sojourn to New Orleans and experience STEM in our 42,000 square foot innovation center. So cool. Thank you. We want to make some announcements. We got a couple of programs coming up, and we're going to be celebrating math. It is March, and you know what March 14 is. March 14 is Pi Day. And so in March, we always do a lot of mathematics. We celebrate math. So we'll be doing a virtual STEM Saturday on March 6th at Grambling State University. That's open to everybody in Northern Louisiana, you know, from Northern Louisiana. If you're in Northern Louisiana and you can get to Ruston, Monroe, or Shreveport to pick up your kit, then have at it. Also, we'll be in Minneapolis, Minnesota with Summit Academy OIC, our partner in Minneapolis, delivering our second STEM Saturday for Northside STEM in Minneapolis. And again, we'll be celebrating math. The first STEM Saturday was a hit with them and they're looking for it again. Now our virtual STEM Saturday, which is open to everyone in the world for STEM NOLA, will be March 13th, Saturday, March 13th, where we're gonna celebrate Pi. Usually in March, I get a big cake made, and they got numbers all the way around the cake, like infinity, like pi, and they have a big pi symbol, and we give everybody t-shirts with pi on the back, and we have a great celebration for the irrational number pi. But we'll be doing math, and check it out, these math days, they're gonna build the what they call it, the dancing pendulum. The dancing pendulum, give me the other pendulum. And then also on March 20th, registration will be opening up for Baton Rouge, for STEM Baton Rouge. And you may ask, why are you doing all these STEM Saturdays? We're doing these STEM Saturdays, different names in different areas, because we want communities to own their STEM. So like when we do STEM Baton Rouge, we're now building a team in Baton Rouge. We bring in college students from Baton Rouge, and we bring in professionals from Baton Rouge. With our partners in Minneapolis, they're working with kids in Minneapolis. They bring in college students from Minneapolis and professionals from Minneapolis. So we build capacity like that, so they don't have to depend on STEM NOLA. We're doing this in New Orleans. We want to come to your city and make this possible so you can do it right in your city. So we're training people on that. So on our math days, we're gonna do a lot of activities, but we're gonna do one activity on the dancing pendulum. And you know, there's a mathematical theory of string and force in motion that if you drop all of these balls at the same time, they begin to dance. And as long as they go through the force in motion and string theory, they actually get out of order, and then they come back to order. Now, the beautiful thing about that is this is a pendulum that we probably paid $79 for some outrageous price. In our STEM boxes, when you sign up for a STEM Saturday, you get a kit and you make your own pendulum. You make your STEM NOLA pendulum out of nuts and bolts and stuff. And what we're trying to show you is that you can start off with an idea. You can start off with an idea and innovate the future with stuff in your home. So any idea you may have, we want you one to first believe, but we want you to know that you can come up with a solution for it. And that's why we want to teach you all a theory about how things work and why things work. So then as you get more smart and get more knowledge, you can build the future. I want you to show that, Brett. Take it out so they can see the pendulum falling back into place. There we go. And for me, this is all mathematically based. And what we do is make mathematics relevant to you. And we make mathematics fun. Someone wants to know, where can they see the recordings? The recordings is at our website, stemnola.com, but also the recordings are on our Facebook page, because we do this Facebook Live, so you always can go to Facebook Live and look at the recordings. And within 2 weeks, we'll be launching a whole new website. And we want to bring as much information to you all as possible. Parents, we're going to have a lot of resources that we have listed on this website across the nation, right? We're just gathering data mining information because we want you to know what you could be doing for your scholars. So I want to say thank you again. Thank you to Abi Soye from BOEING. Thank you to Lionel Johnson. Thank you to the whole STEM NOLA staff and team that make this work. What we've done, I think, is amazing since COVID hit. I have a whole bunch of people standing back there looking at me like I'm crazy, but they made it happen, and we made it happen for you. So thank you for appreciating what we have to offer. See you all next week if we don't see you Saturday at a STEM Saturday. I'm Dr. Calvin Mackey. Y'all have a great day and a great weekend. Bye.